Everyone. Thank you so much for time joining. I'm your host, Fiona Wang, and I am a Senior Communication Manager at DFINITY Foundation. Today, we have our speakers with us on the second workshop, and the topic is Production on Building on the IC, Motoko and Rust. We have our speakers with us, Carsten Jacobsen, Senior Developer Relations Engineer, Hamish, Peebles, Software Engineer building OpenChat. They are going to kick off things off with this workshop, and I will be monitoring for questions. So if you have any questions, feel free to leave, and we will save the Q&A until the very end. The workshop is being recorded and is going to be published on YouTube in the next few days. Without further ado, I'm going to hand it off to Carsten. Carsten, feel free to take it away.
Thank you, Fiona. I will share my screen. So I am going to start with a short presentation about what the Internet Computer is. I'll talk a little bit about Motogo, the programming language, because it's probably new to a great part of our audience. And then we're going to dive into some demos. We're going to first show how to build a very simple dApp in Motogo. I will cover that part, and then Hamish will take over and build the same dApp in Rust. So I will start with the presentation. I always like to start with saying that we're typically using either Mac or Linux when we do these presentations, but you can use any platform. You can use Linux, Mac, Windows. If you're using a Mac with M1 processor, then you may need to install Rosetta. And if you're a Windows user, then use WSL2, and then you'll be able to follow the same commands and the same workflow we're using in our workshop. So just a little reminder that you can use any platform, but there may be some things you need to do. So what is the Internet Computer? See, it's a blockchain that enables developers to build and deploy secure, autonomous, unstoppable, and tamper-proof software, and it runs at web speed, and it's capable of scaling without limits. So it's a really great value proposition right there. What it means is that we can run the entire dApp on chain. That means both the front end and the back end. The entire dApp runs on our blockchain. The smart contracts that we work with, they do contain both the front end, the back end, but also the dependencies and the state of the dApp. We have two programming languages that we are promoting. One is Motogo, which is our own language, and Rust, which is fairly common in blockchain. But anything that can compile to WebAssembly can actually be deployed on the Internet Computer. If we look at some of the traits of the smart contracts, they are composable, which means that they can interact with each other. You can use tokens. You can either use tokens or trade tokens in your dApps. It's very cost effective. It's the price of running a dApp on the Internet Computer is very competitive, and it's really designed with high throughput and scalability in mind. And this is just very high level illustration of the hierarchy of the network building blocks. In the data centers, we have nodes, which is split into subnets, and on these subnets, we run the canisters. The canisters is the smart contracts, which I mentioned holds both the front end, the back end, the dependencies, and the state encapsulated in the canister. What we use to manage our smart contracts and to build our smart contracts and deploy it is the Dfinity Canister Sdk. So I just spent a little bit of time going into what this is, but I'll actually show in examples how to use DFX when we go through the code samples. The Canister SDK is a developer kit that you can use to create a new project. You can use it when you're writing your code, and then you can deploy it either to a local replica, or you can deploy your applications to the mainnet by using this toolkit, DFX. If you want to install DFX on your computer, and that's something you need to do if you want to follow the examples we have here, and if you want to run through the same dapps we are building here after the workshop, then you can go to our documentation at smartcontracts.org, which will also describe how to install DFX. But you actually just run a simple line in your terminal, and then it will install and set up DFX for you. And when you're done installing it, you can confirm that it's running by running DFX -- version. The current version is 0.9.3. I have 2 here, but it's it should show this will show a number of the current version if you have successfully installed DFX. So Motogo is a programming language that we have developed in-house here at Dfinity. And one of the benefits of Motogo is that it supports natively some of the special features and functionalities of the internet computer. For me, I feel it's a very easy language to learn. It's very similar to other programming languages that most developers have used at some point in their career. The way Motogo works is that we use the actor model, and the actor model is a way to encapsulate your functionality in your smart contract and your state. So if you look at the small code sample here on the right, you have a value, which is the state, which is the data we hold in the smart contract, and then here we have a functionality. We have a function that, in this case, just can increment the value. So we have both the functionality and the state in the actor. The way actors work is that they can communicate through messages to each other. So actors can actually talk to each other also across canisters. We are using an asynchronous model. So we use futures, which is very similar to promises in JavaScript. So you can add the async, and you can run your functions asynchronously. We actually don't really use databases or local storage like a disk in the internet computer and in the canisters. We store data in memory, which we also will see when we go through the code samples. And we are exposing the backend functionality through auto-generated IDL files. And we have an interface called Candid that communicates that is the layer between the backend and the front end. But now, after this very brief introduction, and I would really recommend you to go and read more about the concepts and the fundamentals on smartcontracts.org to get a better understanding. This is just a very brief introduction, but go to our documentation and you'll find a lot of information there. But now let's get started building a small dapp. And in this workshop, it's very simple. We just built a small dapp that is a counter with a front end, with a button and showing the value of the counter, and a back end that can increment the value and hold the value, and that's basically it. Some of the things we will learn here is how to use the DFX to create a default application. When you create a new application through DFX, you will get a default template that will provide many of the files that you need to get started. Okay, so I will switch to my code editor. Okay, so this is all the files and the folders that were installed by DFX. Let's go back and get the terminal again. Yeah. So a few things that is worth noting here is that we got the source folder. In the source folder, we have three folders. We have hack assets, and then we have declarations. What we have in hack is the backend, and let's see. Let's just try to start this up so we can see what was actually installed by DFX. Okay, now our local replica is running, and then we just deploy this application. So since this is running on local hosts, all the necessary canisters, like the wallet canisters that holds the cycles that we're burning when we run an application, is automatically installed. We don't have to think about that. Okay, so now we have the default application installed, and if we go up to DFX here and we look in the local folder, there is something called canister IDs, and here we can actually see the canister IDs for the canisters that was installed, and the canisters installed is for the backend, the front end, and for our candid interface. So since we want to look at this in a web browser, we're going to look at the front end canister. So let's copy this. Then we just go to localhost port 8000. Oh, this is actually an existing. Oh, this was the existing one. Oh, I really got that messed up. But actually, it doesn't matter. Let's just go through it anyway. So the three canisters that were installed here, as said, was the backend, the front end, and the candid interface. So in this example, I have already from previously changed the default application to have the counter functionality. In here we can see I have the actor in the Motogo file, where I have the state, the counter value. I have a function that can count, that can increment the counter with 1, and I have a function that can get the counter. So this is what we need to be able to, when we click on this, that we increment, and then we use the get count to show the number here on the screen. This backend, we can actually test that without the front end. One way to do it is, as I mentioned, we can use the candid interface. The candid interface is we have here a web-based representation of that. So if we go to that, and then we need the backend canister. So here we see the two backend functions. We have the count, and we have a get counter. So if we call this one, we'll see we count one up. We started with the initial value of 0. We go back to the file here. We're calling this count, that increment. And if we go back again and call the get count, then we get the current counter value. So we can count this up again. And it'll just keep incrementing the value. And we can get the value anytime with the get count. Another way to test the backend is to use the DFX command line. And the way we can do that is we can call the canister directly. So if we say DFX canister call, and when we run it locally, we want to use the name of the canister, which is listed in the DFX.json. Here we can see the backend canister, which is the one we want. That's the name hack, which we named it when we created the project. And then we want, let's say we want to use the count, and then we just call count. And now we got 4. So if we want to use the get count, we can do the same. And then call this as well. So when we're building our backend, we have at least 2 good ways of evaluating our work. We can either call the functions through DFX, or we have the user-friendly candidate interface to also interact with our backend. Now, let's go and take a look at the front end. And the front end is this very simple website. If we go to the index file, there's really not much here. We just have the logo, we have the button, and then we have a section where we can inject the counter value. If we look at the index file here, we have included the backend functions here, through the candidate interface. It's very easy when we run in the same application. We can just reference the backend, and that is the 3rd folder here we didn't cover yet. But here we have the definitions for the backend, for the candidate definitions. But we can see we have 2 functions here. We have count that takes no parameters and returns a number, and we have get count, also doesn't take a value and returns a number. So we're actually just importing this auto-generated file that describes how to interact with the backend in the front end. And that's what we do here. We import that file here so we can easily reference it and easily use the functions. There are two event listeners to create this functionality in the front end. One is loading. When the page has loaded, then we call the get count because we want to show the number on the screen. If I refresh here, it gets the number 4, which is the current number we have. And then we have another event listener that checks when the button is clicked. And when the button is clicked, we call the count function, and we look for the return value, and then just display that on the screen. So this is a very simple application. It really just have a button that can increment a value in the back end and then show it, but it actually shows the typical flow you go through when you build an app. You have your front end, you have your back end, and you have the candidate interface that makes it possible for these two to talk together. So I think it's actually a pretty good example of how you can build your app. Other things, again, just to mention this one again, the dfx.json is where everything is defined, where we have our front end, where the code lives in our project. And again, the canister IDs, when you want to call your functions, this is where you see where the canisters are deployed locally. If you deploy it to the mainnet, you will get a similar canister ID JSON file. Those show which canisters you have deployed to, and there you can specify if you have pre-created a canister. And I know Hamish is going to do that. He's going to create a canister and then show how this is deployed, specifying the canister you want to use. So I think that was it I had for this small example. I think you got a pretty good preview of how a simple Motogo dapp looks like in a computer. So I will give Hamish the word and stop sharing my screen.
Okay, I will share my screen. Do you see that? Yeah, okay, cool.
Yeah.
So, okay, yeah, I'm just going to build essentially the exact same backend functionality that Carsten just showed, but this time with Rust. So the way to get started is you can use DFX. Well, you first need to download DFX, but once you've got DFX, you can call into, let's just see what DFX exposes. What we want is this new, creates a new project, you see there. So let's do DFX new, and then see what the options are. So we want to use type. With type, you can specify either Motoko or Rust, and it will pre-build a few of the files that would just be standard among those Motoko and Rust projects. And in our case, we don't need a front end, so let's use the no front end option. So DFX new, just check the syntax. Options and then project name. So we want to say type Rust no front end, whoops, and then we'll just call it hack. Okay, cool. And then open up your IDE. I use one called CLion, but you can use any one you want really, as long as it has good Rust support. CLion has pretty good Rust support. Visual Studio Code is another one that's popular that has good Rust support. Okay, when that's loaded, here we go. So not quite sure why it's made a hack assets, because I put front end only. I guess there's nothing in there really. So let's just do a build to make sure things are working. That might take a few minutes actually, first time around. First build always takes a while, but then subsequent builds will be quicker because it just build the incremental changes. So while that's building, we can see what it's given us already, just out the box. It's just a really simple function called greet, which takes a name, and you can see here that it's a query. Query call is fast, but it can't mutate state. It's fast because in the internet computer, you have in an application subnet, which is where realistically all of our stuff will be running, because there's the NNS subnet, which is super secure with loads of replicas in the subnet, but then the applications which don't need that level of security, they run in what's called the application subnets, and they have a replication factor of 13. So when you do a query call, that query will just go to one of the replicas. But obviously, because it's only gone to one, you lose, it's much faster. It doesn't have to go through a round of consensus. Whereas if you do an update call, which is going to be changing state, it doesn't have to change state, but it can change state. that update call will go to one replica and then get gossiped to all of the others. It will then get put into a block. The block will then get processed. The block will get finalized. And only after the block is finalized do you get a response. And that takes roughly 2 seconds-ish. Whereas a query call is just as quick as if you were hitting making a request to a normal like v.2 service. So it could be like 50 milliseconds. Okay, so that's built. Let's just in a new terminal window, let's just start up DFX. Now what this is doing is this is firing up a copy of the internet computer but running locally. And this is what you should be doing for just testing your changes before you're ready to push them to the real internet computer. So here we go. So that started the server. So we can go back and in here just do a DFX deploy, and that will now deploy this code onto the locally running instance of the internet computer. This is gonna have to rebuild everything again because this is rebuilding everything targeting WASM, whereas when I just did a cargo build, I didn't specify any options, and so it just it would be targeting, what does it target? Debug. Not quite sure. I can't remember exactly what it targets, but it's not WASM, and so the build will have to happen again, this time targeting WASM. So okay, yeah, so while that's building, what we want to do is expose exactly the same functionality that Carsten showed in the Motoko example. So we need a get count function, which we can do a query. We can make that a query call because it's not modifying any of the internal state. We're going to need a count function, which returns, which increments the count by 1 and then returns the current count. With Motoko, you have a nice benefit of your candid file gets generated for you, but with Rust that doesn't happen. Okay, that's done. So we can view that canister that we just deployed. So you see that returned really fast, and that's because this is a query call. And again, this is using the Candid UI interface. That just gets deployed for you when you set up the DFX new project. Not actually sure what does that deployment, because it's not specified as a canister in here. But it's a useful little tool to have. It's kind of like Swagger, if people have used that. You know, it just provides an easy interface to kind of hit your APIs. Okay, so let's get rid of this greet function. And we'll be making use of the Cdk macros. The Cdk macros, you need those in order to expose functionality outside of your canister. So by default, when you're creating functions, these functions are not exposed to the outside world. These are private to your canister. If you want to expose a function to the outside world, you need to somehow tell the canister this is a function that you should expose. And how you do that, the easiest way to do that is to use this Cdk macros. So if we want to make something a query call, we just label it with the query macro. And so in our case, we want a get count method, and that will return just the count. Okay, so we will need to hold the count somewhere. So the CDK makes it quite easy to do this. Let's just define an object which can hold our count. So we can call that state. And it will just hold a single field called count. And so using the CDK, you can use this storage API and then get. Now, when you call into this get, you need to pass in the type. You can use the this syntax. And what that's saying is get the type from the storage where the type is state. I actually prefer to do it like this. I think that looks a bit nicer than specifying the type in passing that into the get method. So how this storage works, the storage functionality, is internally it stores a map of all of the types that you've stored. It stores a map of all the values that you've stored using this storage API, and the key is the type. So in this case, I've said, get me the value whose type is state. If that value doesn't exist, what it does is it will create a new value. It will create a new instance of that type using the type's default value. So we can try building that, and you'll see that this will actually have a compiler error. And you see that's because we need to implement default on our type. So we can just derive that. And what that will do is when we call into storage get, in fact, we can dig into that code. So it gets this map. This storage is a map. And then it says, find the entry with this type. Or if it doesn't find the entry, then run this function to create the value. And that function just says, give the default, create the default. One thing though is within this storage function, it actually uses some unsafe code. So I'll talk about that at the end, but basically the way I'm showing right now, this is the quickest and easiest way to use to store values between your function calls, to hold stuff in the canister state. But there are some drawbacks of using this, but I'll save that for the end. Okay, so now that we've added the default trait onto our type, we should now be able to build. Okay, and let's do a dfx deploy. Okay, and we can call into our canister by using dfx call hack get count, and we don't pass it any arguments. Whoops. dfx canister call. Okay, so you see that returns 0, and I guess that's quite obviously the case because at the moment we're not ever incrementing the count. So let's do that next. So this time we're going to be modifying the state. We're going to be incrementing the count, and that's modifying state. So again, this takes no input and it returns a number. This time we want to get the state, but we want to mutate the state. So we need it to be a mutable reference, and here we need to use get mute. What this will do is it will return a reference to the value that we're storing in state of this type, but rather than being just a read-only reference, this time it's a mutable reference. So here we want to say state.count plus equals 1. We're going to increase the state by, we're going to increment the count by 1, and then we return the new count. So let's do a deploy again. Okay. So if we call get count, that's still 0. But if we call count this time, that's now 1, 2, and so on. But let's try get count, and it's 2. But you see, when we're calling this, get count is still relatively slow. And that is because in our candid file, we need to manually update the candid file to tell it the methods that we are exposing in the Rust code. And then if it sees any which are queries, as this one was, the call to the canister, when you use DFX, will know to call it as a query. So you'll get that faster performance. The reason it's slow when we call get count here is because by default, DFX calls everything as an update. We can use this. We can use the query argument. And now you see it's really quick. And then if we get rid of it, slower. So in here, let's add get count, which takes nothing and returns a nat32. So in Rust, it was returning a u32. But then in Candid, that the equivalent type is a nat32. So then we have another method called count that again takes nothing. If this did take some input argument, we just have to put the type in there. And that returns a nat32 again. But this time we don't need to put any, we don't need to use the query attribute, because by default it will use an update anyway, and count is an update. So now when we call get count, it's really quick. And that works because in the DFX JSON, we specify the canister and we specify the candid file. And so when you say DFX canister call and then pass in the canister name, it will look in this candid file for the signature of the method. And from that, it will know what arguments to pass in. It will know how to deserialize the candid response. And it'll know how to call it, whether it should be an update or a query. Okay, we could add a reset function. So it's another update. This returns nothing, so the syntax for returning nothing is just like that. And again, this time we want to get the state, and we want to get a mutable reference to the state, as we did in the count. And so in this instance, we've got a mutable reference to the state, but we want to reset that value back to being the default. And so what you can do is you can just use standard mem take. And what that does is, we'll probably say it here, replaces the destination with the default value of t. So in our case, t is the state type. And so when we call into storage get mute, that returns to us a pointer that says where this pointer points to, that is where your state is. And then by using this standard mem take method, we remove the value from where that pointer points to and replace it with the default, which in our case will be a new instance of this where the count is 0. So let's do DFX deploy again. There it is. So if we call get count now, you'll actually see that it's gone to 0 again. So we'll talk about that in a second, but let's just see the reset functionality working. So if I call get count now, it'll be 0. Okay, cool. So yeah, I guess you saw, oh no, let's just add to the candid file. So we need reset, that takes nothing, returns nothing, and it's an update call. Okay, so the next thing to do is, you saw that after we did the deployment, so after here, the count prior to the deployment was 2, but then after the deployment, the count was 0. And that's because how an upgrade works is, if you expose a method called pre-upgrade, then the replica, when it receives the upgrade message, it will trigger your pre-upgrade function. Then it will do the upgrade. It will assign the canister the new code, the new WASM, and then it will run, if you have one, the post-upgrade function. So in our case, we haven't defined a pre-upgrade and a post-upgrade. And so all of our state here is just stored in the canister heap. And when you do the upgrade, you get a new canister WASM and you get a new canister heap. And so your old heap just gets completely wiped. So in order to preserve state between the two upgrades, what you need to do is you need to push your state to somewhere that will survive that transition from the old WASM to the new WASM. And so where that is stable memory. So let's do pre-upgrade. This is another macro from the Cdk Macros crate. So let's just implement that. What we want to do in here is we want to serialize our state and then push those bytes into stable memory. And so in the CDK, they have a nice API you can use for that, stable save. And in here, we need to pass in, it's a bit weird, but we need to pass in the state like this. And that is because when you use stable save, you see here it does candid write args. And what that does is it serializes the argument you pass in here, T. It serializes that using candid, and then it writes those bytes to stable memory just using the default writer. So we need to pass in something that can be serialized by candid. And candid is actually only implemented on tuples. So the reason I've put it within these brackets with just a comma there, that's the syntax for defining a tuple with one element. So if I passed it in like that, we're just passing in the state as is, but that wouldn't work because the state is no longer, that is not candid serializable. But by doing it like this, candid is then able to serialize it because it's now a tuple with one item. And so this call to stable save, this returns a result because it could fail could be that you've run out of memory. It could be a serialization error. Either way, there are multiple ways in which that could fail. So let's just unwrap that result. And we can try building. We'll get an error, but I think it's quite good to show the process. Oh yeah, that wasn't the error I was expecting to get, but cool. So here we need to pull the current state value out of the state. So we use Cdk storage get, again, as we did in this instance. So this gives us a reference to the value we're holding in the state. We then call into storage stable save to serialize that state into bytes and then save those bytes into stable memory. Let's try that again. Yeah. So now this is telling us that we need to implement argument encoder on the state type. And the way we do that is to just make our object, we add the candid type trait to our type. And so we'll need to import candid type. Let's try that again. Okay, so pre-upgrade is done. So we've got a reference to the current state, then we've pushed it into stable memory. So that looks okay. So now let's do the other part, the other half of this upgrade process, which is post-upgrade. So we now need to do the opposite. We now need to get the value from stable memory and then save that value into the canister heap. So what do we do here? We need to use Cdk storage stable restore. And again, that can return a result. Well, no, that does return a result because this can go wrong as well if deserialization fails, or probably other reasons as well. So we just unwrap that for now. Also, we need to tell it the type to deserialize it onto. So we just pass it there. And then once we've got the state value, we now need to put it into we need to use the storage API so that we can use it on subsequent calls to these get count and count methods. So what we do is Cdk storage get mute equals state. So what we're doing here is this call to get mute. This returns a reference that points to where the value for where the value is stored in the map that this storage API is creating. Essentially, for each type, there is a different reference. And so by calling into this, we get the reference that it won't actually exist in the map yet. So it will create us a new one using the default value. And then we dereference that pointer and set it to be the value that we got from the stable memory. I hope that made sense. But essentially, by doing it like this, subsequent calls to get the state here and here, these will return the value that we set it to after we did the deserialization from stable memory. Okay, so let's just try building that. Oh, it's going to go wrong. I know. Yeah. As I was saying, in the pre-upgrade case, candid is only implemented for tuples. So we need to use that same weird tuple syntax. And this on the right-hand side of the colon, that defines the type that this side is deserialized into. But then on the left-hand side, we can deconstruct that type so that we don't have to deal with the tuple. We can just pull the inner item out of the tuple. So if you see here, state is of type state. Whereas if we'd done it like this, then state would be a tuple with one item. And then to use it, we'd have to do that. And that's just a bit nasty. So it's nicer to deconstruct it just immediately. Okay, so let's try building again. And that failed. And that is because we need the deserialize trait. So in order for pre-upgrade to work, we need to be able to serialize our type in order for, which involves the candid type attribute, the candid type trait. But then for post-upgrade to work, we need to deserialize it, which is a different trait. Because you could have a type which is only serializable, or you could have a type which is only deserializable. So you need to add each of them to cover the pre-upgrade and the post-upgrade. So that deserialized trait actually comes from SERD, which is just the standard serialization library for Rust. So just add a reference to that. And then use SERD deserialize. And now we should be good to go. Okay, so let's do a deploy. Okay, so we've got an error on line 13, which is here. And this is because we are running post upgrade and it's trying to grab the bytes from stable memory. But remember, we didn't have pre-upgrade in the version that we last deployed. So we never called stable save. So when we call stable restore, we'll get nothing. And then when we try to deserialize nothing onto a tuple with one item of type state, it gets an error. And that's why we see the error happens when we call unwrap. Unwrap, you shouldn't really be using unwrap in production code. It's very rare anyway, unless you've done the checks beforehand. But essentially how you should be handling this is you'd want to do like a match, and you'd say in the OK case, do something, and in the error case, do something else. But because this is just a demo, we'll stick with the unwrap. What we need to do is remove temporarily post upgrade, because essentially we want to push out a version which will work with the currently deployed version, which will mean it needs to not try to deserialize what's in stable memory because there's nothing. But then we do want to, when we next do the upgrade, we want it to serialize the stuff to stable memory. So let's do a DFX deploy now where we're not going to be doing the deserialization. So this time we are actually going to lose the state. So if we call get count now, you see it's gone back to 0. So let's just increment that a few times. So the count is now 3. And then if we do a deploy again, nope, let's uncomment that out. Then, so if we do a deploy again, this time, both the pre-upgrade and the post-upgrade are in place. So this time the state should be preserved if I've done it right. So yeah, the count remains as 3. So that is now working. Okay, let's now show how to deploy this onto the actual internet computer, because this is currently still just running locally. So to deploy it to the real internet computer, what you need to do is this. We need to create a canister. You actually need to pay a little bit for the canister if you want to run it on the real internet computer. Obviously, when you're just developing it locally, you don't need to pay anything. You see here, I've just been using a replica which is running locally. And so it's only using up your own compute resources, so you don't have to pay for that. But when you start running it on the real internet computer, you're going to be running that on data centers throughout the world. And you need to pay those data centers a little bit for them to host your code. So the first thing you're going to need is some ICP, because canisters are paid for in cycles, but in order to get cycles, you need to first get ICP, and then you burn ICP into cycles. It's a little bit complex, but once you get the hang of it, it becomes straightforward, really. In order to get ICP, you can use DFX ledger account ID. In fact, I'll show you. You can use DFX ledger help, and it will give you the various options you can use. So in our case, what we want to do is we want to call create canister. But in order to call create canister, you first need a balance. And in order to get balance, you need to call account ID to return your balance. You then need to buy ICP on some exchange like Coinbase or Binance or whatever. And then you can withdraw that ICP to the account specified. In my case, this one. So I've kind of cheated a little bit and I've topped this up already. By default, that's hitting this is trying to go to the ledger canister ID. This is the ledger's canister ID on the real internet computer, but because I didn't specify a network, it's calling to that canister ID on the local network, and I haven't deployed a ledger locally. So what we need to do is we need to use network IC balance. So there's my balance, 0.1 ICP. So that's about $2 or something. In the future, I'm sure that'll be hundreds of dollars, but for now it's $2. And then DFX ledger, is it create canister? Okay, so options and then controller. So the controller, we just want to be the principal that I'm using for DFX right now. So you can use this function, DFX identity get principal. This returns your principal that is being used when you're sending commands with DFX. If you ever are using DFX for something like a real project that you want to ensure you can control in the future, you don't lose access to, then you need to back up your DFX keys. And where are they? I think it's like in .config. No, in I'm not sure actually, but essentially every time you create a DFX identity, a corresponding private key file is created. I can't remember exactly where they are. I'm not going to look into it right now because that might take a few minutes. But if you do end up making like a serious project and you're controlling it through DFX, you definitely want to take a copy, like back up your keys somewhere so that you don't lose access. So let's run that canister create command again. And let's also remember to use network IC. So create canister, and then what do we want to do? So amount, this is the amount of ICP to burn to create the canister. And in my case, the balance is 0.1. There's actually a fee of 0.0002 to create a canister. So the amount I have available is 0.0998. And then I just need to specify the controller, which is this. Does that look right? DFX ledger, network IC, create canister, passing in the amount, passing in the principal. I think that looks right. Here we go. Okay, so it's done the transfer. So creating a canister is a two-step process. You transfer some ICP to a canister called the cycles minting canister. And the cycles minting canister, what it does is it can be used to top up a canister with cycles or to create canisters. So you transfer it, your ICP, and then you tell it, I want to create a canister with that ICP. And what it does is it will burn the ICP into cycles, create a canister, and then top up that canister with the cycles, minus a small fee to create the canister. Okay, so now we've got this canister. In order to deploy to that canister, we need what's called a canister IDs.json file. So what we can do is we can just copy the one that we have from running locally. And when you run locally, your canister IDs are just specified within this .dfx folder, which would be ignored from source control. because every time you run locally, you'll get new canisters and new canister IDs. So you wouldn't want to commit those. Whereas when you deploy to the real IC, in fact, we can just paste the same one. When you deploy to the real IC, it uses this canister IDs.json. And this one you do want to preserve, because obviously that canister is going to be a permanent canister. So this, how this canister IDs JSON works is the outer field is your canister name. Then inside that, you have another entry for each network. So when running locally, it was using this canister ID. But for us, we can get rid of that and we replace it with IC. And we need to put this canister ID there. And now we should be able to do dfx deploy network IC. We also need to use no wallet. Now, this is because by default, when you call dfx deploy, the command is actually sent to your cycles wallet, which then forwards the command on to the canister. Now, when you're upgrading or deploying, only the controller of the canister is able to kick off that command. So if you go via your wallet, this will work fine if your wallet created the canister, but in this case, the wallet was created directly from DFX, and we specified the controller to be the DFX principal. So we need to avoid going through the wallet. So to do that, I've just put in this no wallet argument. So that looks correct. Do we need to specify hack? I think we do, because in the DFX JSON, it's got hack and hack attributes, and we don't want to deploy this one, hack assets, I mean. So to just deploy the one canister, we run this command. Hopefully I did it right. Alrighty, so that looks like it's done. So dfx canister network IC call hack call count, passing in no arguments. Whoops, did that the wrong way around. dfx canister call hack count, no arguments. All right, so that's working. So that is running on the real internet computer. That is no longer just running locally. And we can, let's just test an upgrade. So dfx deploy, yes. That was quick. But yeah, that's it. So that's it done. So yeah, that now has all of the functionality that Carsten showed in his Motoko example, and that's now up and running on the internet computer. So yeah, that's all that I planned on showing for this Rust example. I will grab a link to the code. I've pushed that code to GitHub already, if people want to take a look at it. Oh, I didn't go into the details about why it's a bit unsafe to use that CDK storage method. I'll just quickly show that. So if you see here, state and state2, the Rust compiler thinks that those are two different mutable references, but internally they're both actually pointing to the same data. So this I mean, essentially, you're bypassing some of the checks that the compiler would normally give you. And that's because internally in the CDK, it's using this unsafe, it uses that unsafe block of code. Realistically, it's completely fine to use this, and a lot of projects do, if you're just doing something fairly simple, I think, because it's just really quick and easy. But you just need to be sure that you don't break it by ever taking two references at the same time to the same object. Yeah, I've actually done another talk in the past where I had more time and I went into how you can do it in a completely safe way. But it is a bit more long-winded. But at least then you have all the guarantees that the Rust compiler would normally give you. And so you're completely safe from issues where you could be pointing to the same thing twice. But yeah, that's it. So maybe we could answer some of the questions.
Yeah, thank you, Hamish, and thank you, Carsten. And now we have 20 minutes for our Q&A. So first of all, to Carsten, because there are two questions to Carsten, and I will also copy and paste it in the chat room. But Carsten, you can take it now to answer the questions. Thank you.
Yeah, looking at the questions. So, so the mapping to the subdomain is actually it's something that's done by default. I actually don't know if you can specify it yourself, how you want to do the subdomain mapping. I would say usually when you deploy to the IC, then you get a URL that's formatted like the canister ID dot ic0 dot app, and then you would use some kind of DNS to route it to a more people-friendly domain. So I actually don't know if we can if you have any influence on how this subdomain mapping is done on the ic0.app domain. I don't know if you know that, Hamish.
Oh, sorry, I was just reading through some of the other questions.
So the question is, so the mapping, the canister ID dot, in my case, localhost, and then the port number, or the canister ID dot ic0 dot app. If there's any way you have influence on how that is how that subdomain mapping is done, I'm not aware of it.
Yeah, I'm not sure actually. I don't know. I know that it doesn't work in some browsers. I think if you're in Safari, you can't use a subdomain. You have to use a query string param.
Yeah, that's right. You can do, let's say you use Safari or some other browser that doesn't support it directly. Then you can specify the canister ID as a query parameter, and then it works as well. So I hope this was it was answer. For the second question, can the front end call backend directly with HTTPS and not through the candidate interface?
It is still using HTTPS.
Yeah,
right?
it is. It is. The two ways that you can connect to the backend is either through the candidate interface, or and some prefer to use an agent. We have agents that is basically wrapping the interface, but making a call straight to the canister functions from the front end is not something I've seen.
It's doable, but it's just, I think it's so much easier to use the candid tooling, so everyone just uses that. But obviously all the candid tooling is doing is just converting, well, it's just building an HTTP request. The end result is an HTTP request gets sent. So you could just send that request yourself, or you use the provided functionality to do that heavy lifting for you.
Yeah, if you go in, let's see if I still have that open. I do. I'll just share my screen very briefly. So if you go into the declarations and look at the candidate interface, you can actually see the index.js that is the file that was imported in, let's see, I go down here. The import we make here is actually this file, and you can see here how we are getting that. So yeah, you could do it, but I would say it's a more convenient way to use the provided candidate interface, or use one of the agents. We have agents for different languages, and some of them are community contributed.
Thank you. And also, we have some other questions coming up in the chat room that Hamish and Carsten, if one of you can answer.
So I see you've put one as what is the difference between ledger account or normal account? When people say normal account, I think they mean ledger account. If you're talking in terms of ICP, all ICP is stored in the ledger. And so normal account, ledger account, I think it's just the same thing. When you want to move ICP around, you send a request to the ledger, and that request, the principal that request comes from, the principal that you're using. So if it's DFX, like I showed in my example, you could see my principal. You can only send ICP from an account which is owned by the principal making the request. And you can just send it to any other account. But all of that takes place in the ledger. And so I think just ledger account, normal account is the same thing.
Gotcha.
And then I see
Thank you.
there's that other question. Why does the CDK need to use unsafe? Yeah, it really shouldn't. But this method of accessing stuff stored in the state, I think, was done over a year and a half ago or so. And it's kind of stuck because it's the easiest way to do it. But it kind of circumvents some of the Rust compiler checks. I've actually spoken to the SDK team and showed them how we do it in open chat, where it's completely safe. And it's the recommended way to do it that one of the Dfinity devs called Roman kind of put forward. He's one of the really good Rust devs that they have at Dfinity, and he kind of put out some guidelines for building canisters. If anything, if you're building a canister in Rust, I'd really recommend reading that. For a hackathon project, doing it the way that I showed just then is probably going to be your best option, because it'll just be really quick and easy. But if you're building something that you really want to like take further and further, I'd recommend doing it the way that Roman suggests in his documents. You can find those online if you search like Rust canister guidelines or Rust canister best practices or something like that, and just look for the one by Roman. Give that a read. It's really useful. But yeah, realistically, the SDK shouldn't be using unsafe. Like, I think that's a mistake, but it's there.
Okay, thank you. And also there is one more question that asking that in the query stream parent way, how do you do subpaths? You can also check the question in the chat room.
Yeah, You just do subpath as normal and then put the query string on the end.
See, there's a question about Motogo versus Rust, and I really think it is a question of personal preference. If you have prior experience with Rust, that I would say that is probably going to be easier for you to get productive really quick. If you don't have any experience with either, I feel personally that Motogo is easier to learn. It's similar to a lot of web frameworks and languages. I have a background working with Node and Go and many other languages, and I think there's a lot of similarities in the syntax. But if you're already a Rust developer, that is definitely the quickest way to just continue doing that.
Yeah, I think Motoko would definitely, if you haven't used Motoko or Rust, probably Motoko would be the one to go to if you just want to get up and running quickly. It's so much easier. Rust is good if you're building something more complex and maybe you need more existing library support. But if you're just building a quite simple app, Motoko, I'm sure, will have everything you need. But as your app gets more complex, you may need to start thinking about using Rust just for the library support. But I mean, I haven't really used Motoko much myself, so I might not be the best opinion, really, the most valuable opinion in this case.
Let's say Motogo is the language we have most documentation around. If you go to our documentation, smartcontracts.org, you'll find a lot more documentation on Motogo. So that and we also have our examples, GitHub repo, github.com/dfinity/examples. We have currently much more examples in Motogo, but we're trying to make it more even. So both on the documentation side, but also on the example side, we try to be more even on the amount of examples and documentation we provide.
And also, you know, Motoko is built by people internal to Dfinity, and it's built purely for the internet computer. So everything is very intuitive and easy. So in the two examples we just gave, you know, Carsten had to write far fewer lines of code than I did to make it work. I see someone ask, can we have nice URLs when we deploy? That is coming in. Do you know, Carsten? Do you know what timeline that will be around in? It will be at least a few months.
Yeah, it's definitely on the roadmap.
Yeah, I can't remember which what are they calling them now? Which release or whatever it's put into, but it's there. It will be a few months away though. And so for now, you have to use canisterid.ic0.app.
Okay, thank you. And we still have 6 minutes to our workshop. So if you have any questions, please feel free to take advantage of the rest of 6 minutes. You can also check today's workshop on YouTube in the next few days. Okay, Hamish, here's one.
Yeah. Oh, I guess I'll read that out because I guess people watching this back may not see the actual question. But Psycat asked, can we do another talk but covering advanced Rust? And yeah, sure. Yeah, see, the serialization and deserialization is quite a key point. Like when you're upgrading your state, how to add new fields onto types and have it just to keep the code as nice as possible without having to like redefine everything a second time. There's quite a few talking points around that. But yeah, that would definitely need another talk.
Okay, thank you so much for all of you joining today's workshop, because I see you have a lot of questions towards the Supernova Hackathon. Stay tuned on our workshop, and all your questions will be unlocked to keep listening, watching our workshop today. And we have this production on building on IC. Thank you so much for Hamish and Carsten for your time, and thank you so much for all your developers' time joining us. Stay tuned. Thank you so much.